All right, here we go. So first we're going to review what we already know. We're doing is just solving for x. We're going to distribute that 2. Over here on the left, 2x minus 3x, that's the opposite of x. Now remember, personally, I like my variables to have positive coefficients. So I would have added x to both sides and subtracted 5 from both sides. Does not mean that's what you got to do. It's fine. Then I get x is negative 11. And again, if I want to check it, says I'm supposed to get 5. Let's see if I do. Yep, I know it's right. Okay. All right, this is one that lots of folks make mistakes on because they see that 5 minus 2, they just want to jump to it and do it. No. Remember, the distributive property, that's a way to show folks to multiply. It's a way to multiply through something that can't be combined any further. You multiply before you do any kind of adding. Okay, so we're just going to rewrite the 5 down. Ooh. Sorry, I'm yawning. Okay. We're going to distribute the negative 2 through. So negative 2 times 3 is negative 6. Negative 2 times the opposite of x is positive 2x. So over here, 5 minus 6, negative 1. I'm going to isolate the term that has the x in it, which is 2x. It's positive 2x. I like it over here. I'm going to add that 1 to both sides. And I'm going to end up with a fraction, which is fine. There's nothing wrong with that. Again, when we have quizzes and tests, and you want to check that. Let's see, common denominator is a 2. That's going to be what, negative 9 halves? Half of 2's 1. That's 5 plus 9. Yep, guarantee I got it right. Okay, we got 2 things left to learn about just solving equations for right now. One is, what do you do when we have variables on both sides? Okay, so let me get a highlighter up here. Well, there it is. We've got a negative 4x on the left side of the equals. We've got a negative 9x on the right. Now, it does not, again, it doesn't matter what side you decide to put them on. Personally, I put the variables on the side that's going to create a positive coefficient on the x. And the way you pick that side is bring all the variables to the side where there's already more of them. Like right there. Negative 4 is a bigger number than negative 9. Negative 4 sits, that's positive 4, duh. Negative 4 sits here. Negative 9 sits there. Any number to the right of another number on a number line, that's a bigger number. So let me think of it this way. Is it better to owe $4 or owe $9? Ideally you don't owe any money, but you'd rather owe less. So that's a bigger number. So I'm personally going to bring the x's to the left. So we'll make negative 4x is already there. I'm going to add that 9x to both sides, which means I'm going to take the 10 to the other side by subtracting it from both sides. The reason I took the variables to the side where there's more of them is because that way when I add them together, it'll be a positive number. Negative 4 plus 9, that's 5x. So I'm going to divide both sides by 5 and end up with negative 2. Again, check it. We're looking to see, is this a true statement? Everywhere there was an x, I stuck in a negative 2. So here's 10 plus 8, 18. Negative 9 times negative 2, also 18. It is. Now, like I said, that was my choice. I didn't have to do that. I could have brought the x's to this side, which would have been less to move. And then I would have divided both sides by -5 and gotten the exact same thing. It's fine. Okay, oops, is there another one over there? There's not. Okay, this one, there's stuff to do on each side before I start moving things around. So let's do that. Let's distribute that 3. We'll distribute our fourth. A fourth of 32 is 8. A fourth of 56 is 14. Okay, now look at this. 9x, 8x. 9 is bigger than 8. I'm going to bring my x's over here. 9x is already on the left. Subtract 8x from both sides. 14's already on the right. Add 12 to both sides. And then we're done. X is 26. Okay. All right. Now, sometimes something seemingly weird happens. Let's say we're working on this equation. Here's 15x plus 6 is 15x. You're like, okay, I've got to get my x's on one side. Subtract 6, and I'll end, see, 15x minus 15x, that's 0 x's, which is just 0. And there's -6. There's no variable left. What does that mean? Hang on. What about this one? If I distribute this through, and then I move around and get all my variables on the same side. I'm going to add 8y to both sides. I'm going to add this 2 to both sides. -8y plus 8y, again, is 0. Y's, which is just 0. -2 plus 2, also 0. Variable disappeared there, too. Okay. Well, what happens is there's 3 different outcomes when we're solving for linear equations in one variable. If we were talking about how many solutions there are, like the ones we did before right now, all just had one solution. You know, like the 2 we did to start the class. The solution was x is -11. The solution was x is 15 halves. The solution was x was -2. X was 26. That's one solution per linear equation in one variable. Okay, but this, there's no one solution. It doesn't say x equals something on neither of those. So our other 2 options is that sometimes there just isn't a solution. And let's face it, all problems in life, not everything you can figure out. Like sometimes there's just no way it's impossible. Like there's no way for this to happen. Okay. But sometimes everything's a solution. So there's infinitely many solutions. So here's what this means and how you can tell. When I guess since we're taking notes, I guess let's put it down here. For both of those, what will happen with the equation is the variables will disappear. Okay, so if you end up no variables at all, variables just disappear. It's going to be one of these 2 that's happening. You're either having all the numbers will work or none of the numbers will work. And the way you tell is if it doesn't have a solution, you'll come up with a false statement. If everything works, you'll come up with a true statement. Okay, so come back up here. 0 does not equal -6. That is, well, hang on, let me do this. With an equal sign, it's false. You know, if I put the does not equal, it would be true. 0 does not equal -6. Now, the thing is, you don't answer it true, false. What you do is you say, okay, that's not true. Then there is no solution. Like, I don't care what you do. You can pick x's all day long and try to plug them into that, and it will never work. The left side will never equal the right side. Okay, now on the other hand, on this one, the variables disappeared, and I got right there, 0 equals 0, which is a true statement. What that means is that y can be any real number. Okay, so real numbers, for right now, any number you've ever learned about is a real number. There's other kinds of numbers you'll learn about in algebra too. But for any number you've ever dealt with or even thought about, it's a real number right now. There is a symbol for the set of real numbers. It's this little funky looking R. It's like you double up the legs. So most of the time, people just say this. And the way we read that, Y is an element of the reals. Because the set of real numbers, people just call them the reals. This symbol, it looks kind of like a C, and then you draw a line through it. That means element of. Like what we're doing is talking about sets. Like if there's a set of people that are the, I don't know, the quarterbacks on the Green Bay Packers. Actually, this may not, is Aaron Rodgers still the quarterback? There was all that hullabaloo going on this spring. I don't know what happened. But if there's a set of people that all have, or set of anything, and they all got something in common, and you say, oh, that's a member of that set. That's an element of. So that's just saying Y can be anything. Now, here at Papillion, they answer that question as infinitely many. Okay. I'm not a fan of that. Let's just put it that way, because I don't think that's accurate. Yes, there are infinitely many answers. Like, how many real numbers are there? Like I said, any number you can think of is a real number. So, yeah, there's no way I can count them all. Infinitely many means there's no way I can count them all. Like, even when you think you've counted them all, there's more to count. But that, you can't just say, here, let me give you an example. What if I gave you this set of all even numbers? Okay, well, there are infinitely many even numbers. I get it keeps going both directions. But that doesn't include all the odds. And all the odds would make this true too. That's why it's answering it with infinitely many. It's kind of a weird way of doing it. Because I'm not asking you how many solutions there are. I'm asking you what the solutions are. And I'm telling you that any number you can think of, when you go back right here and you plug it into that equation, will make it true. For example, let's just pick some random number. Let's pick -7. I'm going to change that parenthesis to a bracket just to make it easier to look at. Does that equal -8 times -7 minus 2? -27 here. I'm going to get, what, 54 on this side? Oh, look at that. It did make it true. Pick some other number. Let's pick y is 1. This equation a lot. There it is. Wait, what did I just do? Y is 1. Oh, duh. I lost that negative right there. It's like, wait, I'm not going to get the same thing. It's too early in the morning. Got the same thing. Not the same numbers. Like this 54 and 54, -10, -10. Those aren't the same numbers. But remember, an equation is a statement of fact. -10 does equal -10. 54 does equal 54. I don't care what number you pick. No matter what you plug into that, that will turn out to be a true statement. Because every single real number in the world makes it true. Okay? And this is, still yawning. Let's go through here and try some more. They're just a little bit longer. I'm going to distribute the 2 over here. Distribute the 12 right there. 8x plus 4, that's as good as the left side looks. -4x plus 12, that's 8x minus 12. Now, like I said, try to get your variables on one side, numbers on the other, constants on the other. variables disappeared, it's a false statement. That means there is no solution. It means if you came back right here, any number you plug in for x, I don't care if you try all the numbers you can possibly think of, none of them will make that true because it's impossible for that to equal that. Okay, now when you really know what you're doing, when you get to this point, you would have realized it's no solution because 8x and 8x are the exact same thing. If you add 4 to what that is versus add negative 12 to what that is, those can't be the same number. They're never going to equal each other. Okay, all right, this one over here on the left, let's see. 10 minus 9 is 1. 5r minus 8r, that's negative 3r. If I get the r's on one side, constants on the other. True. That means everything works. So I'm going to say r is an element of the reals, which means that there are infinitely many solutions. Every single real number in the world is a solution. But again, when you got to this step right here, see how both sides say the exact same thing? In mathematics, we call that an identity. Something is equal to itself. If you get to the point where you have an identity in an equation, you know everything's going to work because that's just a true statement. Negative 3r plus 1 does equal negative 3r plus 1. Now, a lot of times people don't notice it because they're just so used to getting all the variables on one side and numbers on the other and da-da-da-da-da. But if you're paying attention right then, you knew that everything was going to work. Okay. And then just a couple more things. This was actually on your homework last night. So I threw it on there just to see if you remembered what it is. Every single thing that I talk about, it's the answer when you... Okay, so if I'm saying, what's a sum? Okay, it's the answer when you add numbers up. What's a difference? It's the answer when you subtract. What's a product? It's the answer when you multiply. What's a quotient? It's the answer when you divide. Okay, now, sums and products, when you multiply and add, nobody cares what order you do it in. So if I've got something that says the sum of A and B, technically it does not matter whether you put A plus B or B minus A. What did I say? B minus A. Oh my gosh. A plus B or B plus A. Doesn't really matter. I say just whatever's said first, write it down first. Because it does matter when you're doing a difference. Like 4 minus 6, not the same thing as 6 minus 4. Not even close. Okay? So if it says the difference of C and D, whatever they say first has to come first. That means C, that means C minus D. Okay, so product, the product of E and F would just be E times F. Now think about this, E times F, I don't need to put a symbol in between them because those are both variables. If you stick two variables right next to each other, you're telling me to multiply. Now, if it was the product of 7 and X, again, don't need to have a time sign or anything between the 7 and the X. The only time you have to is when it's a number or something. Or actually, when you could do like the product of 8 and 9. That means do 8 times 9. You can't just put 8, 9. That's 89. That's different. So really, you don't need anything if one of the two is a variable. Okay. And then quotient, again, it matters what order you divide in. 10 divided by 5 is 2. 5 divided by 10, that's a half. Different numbers. So if it says the quotient of G and H, whatever they say first, G divided by H. Algebraically speaking, it's easier to write as a fraction. Like if you're going to work with it in an equation, fraction is the way to go. And then right here, pay attention, save yourself some work. It says write an equation for each of the following. Don't solve these equations because you're going to, like when you do the homework tonight, you're going to have already solved a whole bunch of equations. We've already looked to see if you can do that. This is just going to be, can you rewrite this as an equation yourself? And then, yeah, usually we're going to solve that. But so you want the difference of, so you know you're subtracting, the difference of 7 and some number. Well, that's a variable. And if they don't tell you what to call it, it's your choice. Personally, I'm a big fan of n for number. A lot of folks like x better. So the difference of 7 and a number is 10. Okay, the quotient, which we're going to divide, of 3 and a number is 15. Okay, I think I got one last one. I do, right here. So we've got 96 feet worth of fencing, and we're going to enclose a rectangular pen for your dog. So to provide sufficient running space for your dog, the pen should be 3 times as long as it is wide. Find the dimensions of the pen. So say here's the width of it right here. Here's the length of it right there. Just pick a variable. Let's say we want the width to be x. I don't know how, because I just don't know. Variables are things you don't know yet. But the length needs to be 3 times as long as that. Well, 3 times an x is just 3x. And then think about what you know about a rectangle. If the right side's x, so's the left. That's how long it is. 3x and 3x. So they're saying you've got 96 feet worth of fencing that you can use. So that 96 feet worth of fencing is going to go around the pen. So that's a perimeter. So a perimeter is a distance around a shape. So what I'm going to do is take all those lengths, add them up, and say, okay, it's 96. So 3x and 3x, we're up to 6x, 7x, 8x. And then if I divide both sides by 8, x is 12. Okay, now go back to the picture. If x is 12, oh gosh, what just happened? If x is 12, this side over here is 12. This side is 3 times that, which is 36. So when they say find the dimensions of the pen, everything's in feet because we're talking about feet. Then the pen is 12 feet by 36 feet. You could say that. That's dimensions. And when you put that little X on dimensions like that, people say the word by. Okay, so 12 feet by 36 feet. Or you could say, another way is the pen is 36 feet long and 12 feet wide. That would be a good way to answer it. But usually when they just say dimensions, they'll say 12 feet by 36 feet. All righty, that's today's stuff.